HVAC temp rise formula used to measure airflow CFM. Learn the exact steps to measure supply airflow using temperature rise and adjust blower speeds correctly for heating versus cooling. To calculate airflow in cubic feet per minute using the temperature rise method, measure supply and return air temperatures with accurate thermistors or calibrated digital thermometers placed at least 3 duct diameters downstream and upstream to avoid stratification. Use the formula CFM equals the sensible heat output in British thermal units per hour divided by 1.08 times the temperature rise. And when working with gas furnaces, confirm the declared steady-state input and rated efficiency to compute true sensible heat rather than relying on nameplate values. For electric heat, convert kilowatts to British thermal units by multiplying by 3,401 and then divide by the temperature rise times 1.08. Always run the furnace long enough to reach steady state, usually 20 to 30 minutes under normal ambient conditions, and log temperatures every minute to detect drift. When testing cooling, switch the blower to the higher cooling speed before measuring, measure supply and return wet bulb temperatures if possible to account for latent load, and use sensible heat only when calculating airflow for heating tests. Place the return temperature probe in the center of the return grill or use a well-mixed sample box for multi-return systems, and seal test doors and registers to match typical operating duct leakage. If you see greater than 5 degrees Fahrenheit variance between multiple supply readings, average them only after confirming equalized blower distribution. Compensate for filter loading by noting static pressure across the filter and, if necessary, remove or replace the filter to replicate manufacturer test conditions, then remeasure. Document ambient conditions, equipment serial numbers, and blower tap positions so results are repeatable. Convert airflow adjustments to blower tap or variable speed settings and retest after every change, because motor characteristics and system resistance produce nonlinear changes in cubic feet per minute. For best accuracy, cross-check temperature rise derived CFM with a flow hood or traverse measurements at least once per year to validate your method and calibrate offsets. One of the most common mistakes is using the wrong sensible heat value for the furnace, which skews the CFM calculation. Fix this by calculating sensible heat from measured output and verified efficiency rather than nameplate input. One of the frequent errors is failing to set the blower to the correct cooling speed before measuring airflow for cooling mode performance. Fix this by switching the blower to the manufacturer's recommended cooling tap or variable speed setting, then rechecking supply and return temperatures. One of the typical issues is poor probe placement and temperature stratification causing noisy or biased readings. Fix this by placing probes away from register edges, maintaining 3 duct diameters of straight run when possible, averaging multiple readings, and documenting probe locations. BigHomeProjects.com lists vetted local HVAC contractors and provides a searchable directory tied to homeowner reviews and specialties relevant to airflow testing. It helps homeowners find trusted technicians for accurate temperature rise and airflow measurements while giving contractors a place to showcase services and get work.